Hello. So today I'm going to be solving another question from exam 1, and this is going to be question 3. Sorry, I forgot to make a note of that. So we're going to be rotating around the volume of the solid. So we are giving a area bounded by two functions of y equaling x and y equaling x squared, and we are rotating around the line of y equals 2. So this point here will be where we're rotating around the function. And I've taken the liberty of already labeling each of the functions. So y equals square would be this function here, and then y equaling x would be this secondary function here. So then we would rotate the entire solid around 2y, and we would get something kind of resembling a shape that's something like this. It's a bit hard to draw while I'm recording, but something like that. Around the point y equaling 2. So rotating around that line, we would take the point of intersection by setting equaling y equals x squared, and then y equaling x to each other. So we get x squared equals x. And the point that this would intersect in, we would plug the point in, and plug in the point 1 squared is still 1, and x equaling 1 is still 1, and those are equivalent. So that would be our point of intersection. So when we were trying to define the limit, we would use a integral that is bounded between 1 and 0. So we would take by using the washer method, since it's two functions bounded by an area and it's rotated around this axis, since the radius is rotated around this axis and there's a distance of 2 in between the upper function and the lower function, it would resemble something like this: 2 minus x squared minus x cubed, moving my camera down, and then multiply this by pi. Now, solving for this integral, we would take this 2 pi over minus x, and we would factor this out as x squared minus x times x squared minus x, and this would give us x over 4, x minus x. Since essentially we're multiplying two variables to a power, we would just be adding the powers together, so it would be x cubed, because 1 plus 2 is 3. Subtracting that again would give us another x minus 3, then minus x squared. So multiplying this out, just to check myself, we're multiplying here and we're multiplying here. That's negative 3, or x to the negative third power. X squared times x squared is x to the fourth power. Negative x times x squared, that is negative x to the negative 3 power. Or sorry, negative x to the third power. And then negative x times negative x, I caught my mistake here. That'd be x plus x squared. So since these are common factors into the same power, we would combine these two, and that would give us 2x to the third power plus x squared minus x to the fourth power, and this entire function would be subtracted by 2 to the integral of 1 over 0 dx, and we should also include our dx here just to keep things consistent. And taking integral, obviously these are unnecessary parentheses. We're taking our integral, that would give us 2x minus x5 over 5 minus 2x over 4, or to the fourth power divided by 4. This could be simplified to 1 over 2. Just gonna minus sign, plus x cubed divided by 3 would be solving within the limits of 1 and 0. So that would give us 2 minus 1/5 minus 1/2 plus 1/3 multiplied all this by pi. And of course, since 0 to the 0 power is still 0, or 0 to the 3 power is still 0, divided by 3 is still 0, so we can disregard our secondary function, so it'd just be minus 0, and we can ignore that. So 2 minus 1 over 5, that is 4 over 5 plus 5 over 5, which would give us 9 over 5. Give us 9 over 5. 9 over 5 minus 1/2, cross multiplying. Of course, this is just a bit of busy work. It would give us 18 over 10, or what in the world? Yeah, it would give us 18 over 10 minus 5 over 10, equaling out to 13 over 10 plus 1 over 3, which plus 1 over 3, 1 over 3, 10, that would be 10 over 30, and then 13 times 3, that's 26 plus another 13, 26 plus 13, let me do some quick math here. 26 times plus 13, that's 36, so that'd be 39, I believe. Actually, in fact, let me just use a calculator here real quick to solve that. Yep, that'd be 39. So 39 over 30, which our final solution would be 49 over 30, and then remembering that we multiply this entire function by pi, we can bring this pi down over here, and our final area of the solid would be 49 pi over 30.